Alright guys, so today we are going to practice with some angles of depression and angles of elevation. Hopefully you got the chance to watch the YouTube video that was also posted to Canvas first before taking notes because it is very helpful. It is posted under today's date. I think it says angles of elevation video. But an angle of elevation is an angle from a horizontal line looking up. So in our picture, we have a girl looking up at a hang glider, and that is the angle of elevation. And our angle of depression is the angle from the hang glider looking down. Notice both of those use a horizontal line, not a vertical line. Since they are both using a horizontal line, and our horizontal lines are parallel, our angle of depression and our angle of elevation are actually alternate interior angles. So they will almost always be congruent. Let's practice labeling some of these angles. Starting with angle 1. Since angle 1 is below this horizontal line, it is the angle looking down from the bird to the balloon. So this is an angle of depression. So angle 1 is an angle of depression from the bird to the balloon. Angle 2, notice angle 2 is above this horizontal line. So it is an angle of elevation. This is the angle of elevation from the balloon to the bird. It's like the boy in the balloon is looking up at the bird. Angle 3 is below that same horizontal line. That is the angle of the boy looking down to the ground. So this is an angle of depression from the balloon to the ground. And angle 4, notice angle 4 is above the horizontal line. So it is the angle of elevation because it's the angle going up from the ground to the balloon. From the ground to the balloon. So an angle of elevation is the angle going up, and the angle of depression is the angle going down. All right. So let's practice drawing some pictures and solving some word problems. Our first example says, you sight a rock climber on a cliff at a 32-degree angle of elevation. So I know I'm using angle of elevation. Your eye level is 6 feet above the ground. So I'm going to draw a picture of me and pretend that I am 6 foot. 6 foot. I am looking up at a rock climber. So here's my horizontal line. Our angle of elevation always has to be from a horizontal line. So here's my angle of elevation to a rock climber. So here's my rock climber. I'm going to put an RC for rock climber. This is a 32-degree angle of elevation. And then it says, I am standing 1,000 feet from the base of this cliff. So that is this distance right here. I am 1,000 feet from the cliff. We want to know what is the approximate height of the rock climber from the ground. So I want the whole height from the ground to the rock climber. So that's this height. But to find that height, I need to look at my right triangle that we have just created and find this height first, which I labeled with an X. Once I find X, I would then add it to my height, which is 6 feet. Whoa. So this whole distance is X plus 6. So now if we look at our right triangle, we can solve this using tangent. Our X is opposite of our 32-degree angle, and our 1,000 feet is adjacent to our 30-degree angle. So we are going to use tangent, which is opposite over adjacent. So the tangent of 32 degrees is equal to X over 1,000. So I need to multiply by 1,000 on both sides to solve for X. 1,000 divided by 1,000 is 1, so those cancel. So X is just equal to 1,000 times the tangent of 32 degrees. If you type that into your calculator, you should get 624.9 feet approximately. But that is not the height of our rock climber. That is the height from my eye level. My eye level is 6 foot tall, so I need to add 6 to get 630.9 feet. Let's try another one. Instead of an angle of elevation, we now have an angle of depression. It says an airplane pilot sights a life raft at a 26 angle of depression. So here's my airplane up in the sky. The angle of depression down to a life raft on the water is 26 degrees. Remember, I have to take my angle of depression from the horizontal line. So this is where my 26 degrees would go. And down here is my life raft, and I'm going to mark it with an R. It says the airplane's altitude is 3 kilometers. That means it is 3 kilometers off of the ground. So that is this length right here. So now we have created a right triangle. And we want to know what is the airplane's horizontal distance, D, from the raft. So we want the horizontal distance, which is down here, the base of our triangle. We don't know anything about our interior angles of our triangle besides the 90-degree angle yet, but we do know that our angle of depression is 26 degrees. And since our angle of depression and our angle of elevation from the raft to the airplane are alternate interior, I know that this angle also has to be 26 degrees. So now we can use tangent to find our distance. Our 3 kilometers, this side is opposite over 26 degrees. And the distance we are looking for is adjacent towards 26 degrees. So the tangent, which is equal to opposite over adjacent, of 26 degrees would be 3 over our distance D. Since D is in the denominator, I need to multiply by D on both sides of my equation so that these D's cancel. And I have D times tangent of 26 degrees equals 3. Now to solve for D, I need to divide by the tangent of 26 on both sides. So D is equal to 3 divided by tangent of 26 degrees. And if you type that into your calculator, you should get approximately 6.2 kilometers. Our last example is a little bit different. On this example, we are actually going to find the angle of elevation. This example says a 30-foot ladder is propped up on a 25-foot building. So imagine a ladder propped up on a building. It is usually at a slant. So here's my ladder. It is 30 feet long. And it is propped up on a 25-foot building. And our building is going straight up. Here's the ground at the bottom. Find the nearest degree, the angle of elevation of the top of the building from the point where the ladder is touching the ground. Well, here's the point where the ladder is touching the ground. So the angle of elevation to the top of the building would be this angle right here. So I'm going to mark it with an X. To find the measure of angle X, I can use sine. The building, which is 25 foot, is opposite of our angle, and the ladder, which is 30 feet, is the hypotenuse of our triangle. And sine is opposite over hypotenuse. So sine of our angle X is equal to opposite, which is 25, over hypotenuse, which is 30. To find the measure of angle X, we need the inverse sine, or sine inverse of 25 over 30. Anytime you're trying to find an angle measure, you have to use the inverse of that trig function. If you type in sine inverse of 25 over 30, you will find that X is approximately 53 degrees, or 56 degrees, I'm sorry. And that is our angle of elevation from the ground to the top of the building. That is all I have for you today.